Welcome to Metalcoating. A small brief about Metalcoating SRL Italy. The company started in 1985 in Milan. The company always took care about the continuous demand of the high-end market. The main target of the company was always been technology, innovation, and quality. The last 20 years also health and environment looking for heavy-duty and safe coating. The engine of the company is a mix of ideas, high sophisticated laboratories and the capacity to engineering our new products with passion. Carbonip is a patented technology from Metalcoating SRL whose aim is to be the possible substitute of hexavalent chrome in several sectors. It is characterized by the absence of heavy metals and fluorine. It is environmentally friendly thanks to the non-continuous disposal, and its wear rate is 10 times lower with respect to the hexavalent chrome. It consists of an electrolytic nickel phosphorus alloy in which boron carbide nanoparticles are homogeneously dispersed inside. This combination gives some important characteristics such as great corrosion and wear resistance, high hardness, and deposition rate. On the right, some SEM, scanning electron microscope, images describe the coating. The black dots represent the boron carbide while the lighter region evidences the nickel phosphorus matrix. Carbonip was formulated to provide a good stability, an easy handling of the bath and low environmental risks. There's the possibility to use only the matrix of nickel phosphorus as a substitute of electroless nickel. In this slide, several possible applications are shown. Carbonip is quite suitable among metal substrates such carbon steel, copper, and aluminum and their alloys and cast iron. This technology is compatible to components of different size and shape. There's the possibility to apply a second layer of Teflon to enhance dramatically the corrosion resistance and reduce the friction coefficient. About 3 microns remains embedded inside the carbonip coating thanks to the porosity of the layer. Of course, for external deposition it is mandatory the rotation of the components to reach uniformity. We can produce bigger sample with a maximum diameter of 500 mm, and a maximum length of 3,800 mm. Polishing could be applied through grinding or other hard tools. In this slide some mechanical properties are shown, the microhardness value before and after the thermal treatment, and the percent in weight of phosphorus and in volume of boron carbide. The following slide shows a comparison among the carbonip and other coatings. Thermal treatment was carried out before testing. The hardness of the carbonip is in between carbide and chrome. Pin-in disc test was performed to evaluate some important properties. First, the friction coefficient among carbonip, chrome, and tungsten carbide. Tungsten carbide results could not be the real value because the pin of the instrument is made of the same material. The wear rate results show carbonip value 10 times lower than chrome and quite close to tungsten carbide. The concentration of boron carbide is 10 grams per liter. It is possible to tune the wear rate according to the boron carbide concentration from 0.1% to 1% in weight. A relationship with wear rate is given by weight loss where there's a visible difference between carbonip and chrome. This table shows a comparison between chrome, tungsten carbide, carbonip and carbonip matrix investigating hardness, corrosion resistance, environmental impact and wear resistance. The two following slides compare carbonip, hexavalent chrome and trivalent chrome, a possible substitution of chrome 6, pondering both process conditions and final properties. The two following slides compare carbonip, hexavalent chrome and trivalent chrome, a possible substitution of chrome. The appendix shows some application of the Carbonip. In the first slide, some hydraulic cylinders are visible starting from the number 1, the raw material. Number 2 and 3 consist of Carbonip with 10 grams per liter and 5 grams per liter of Boron Carbide nanoparticles. The following samples, number 4 and 5, are polished, the first one with a taping machine and the second one through a diamond tool. The last 2 specimens are characterized by a double layer, Carbonip plus Teflon. In particular, the number 7 after an abrasive cloth contribution where 3 microns of Teflon are stacked on the Carbonip thanks to the porosity of the coating. In the second slide, some extrusion layer bubble film components where Carbonip and Teflon were applied. In the last slide, we have on the right an extrusion screw while on the left a plastic mold reinforced with alumina where both Carbonip and Teflon were applied.